All right, team, we've got tree diagrams today. Another word of Bayes' theorem is what it's referred to as. And so if you ever hear me say Bayes' theorem, what I'm talking about is tree diagram. So you've probably seen a tree diagram in probability before, but what it does is it displays all possible outcomes in a tree-like fashion of a certain event. And it's useful, the reason we use them is when there's given conditions. And so this very first question, we have a certain number of villagers in this place called Salem that are witches. And what you need to know about tree diagrams is that anytime you're given a percentage corresponding to a certain condition, you're also given another condition without like them telling you. That means that 82% were not witches. So you have to think about reading the percentages in terms like that. If 18% are witches, that means 82% are not witches. And that's actually going to build the first part of my tree. So my tree looks like this. I'm going to spread it out so I have plenty of room to write. 0.18 witches. And that also means 0.82 not witches. It's important to label with words what these numbers mean, so just keep that in mind. Okay, every villager is put on trial to determine if they practiced witchcraft, so some spooky stuff. About 88% of the witches were found guilty. And so in the witch category of the tree, 88% were found guilty, which means 12% were found not guilty. So remember, you're always given another condition, which means 12% not guilty. So you're always given kind of two percentages, even though they only state one of them. So 88% of the witches guilty, which means 12% not guilty. Okay, and then same thing on the other side, 16% of the innocent means not witches, were found guilty, which means 84% were found not guilty. Okay, so that's my other branch. So of the innocent people, I have 16% are guilty, and that means 84 not guilty. There's my tree. There's all of the wording in there as well. So very first question, once you have all your information labeled and organized in a tree, what's the probability a randomly selected villager is found guilty? So there are two ways to be found guilty. You can be a witch and guilty, or you could be not a witch and also found guilty. That wouldn't be fair, but there are two ways to do that. So I'm going to write down two ways. You could be a witch and guilty. And there is a probability for doing that. Or, which means plus, as you know, you could be a witch, or not a witch, excuse me, but also still be found guilty if you're put on trial. Okay, so those are the two ways in order to answer the question to be found guilty. And so very, very simple. The reason why we do these tree diagrams, and I love them, is to be witch and guilty. You just multiply when you work your way down the tree. 0.18 times 0.88. Or means plus, same thing on the other side. 0.82 is to be not a witch, and 0.16 is to be guilty. All you have to do is add those two numbers together, and it gives you 0.2896. And that is the probability that any villager, any person in this town, whether they're a witch or not, was put on trial and found guilty. Okay, so the next question is, what's the probability that a witch is not found guilty? And so this is our given condition. We're only looking at witches here. Not guilty. So if we're only looking at witches, we're only looking at this part of the tree. And it's already divided up into 88% and 12%, so not guilty is just 0.12. We're only looking at witches. So half the tree in this case. The other way to think about this is, what's the probability that a witch is found not guilty? So probability of not guilty given witch. is 0.12. That's the way to write it kind of like in symbols. Okay, let's look at the third question. If a villager is found guilty, so this is our condition, so probability of something, what is the probability they are a witch? I'm writing this in words, given they are found guilty. And so we do have a formula for that, which given that they are guilty. So the given condition is if you know the person is guilty, that's the given part, what's the probability they are a witch here? So I'm going to start by writing my formula. The formula for that is probability of witch and guilty divided by the probability of being found guilty. And so witch and guilty, I'm just looking up at the tree. Witch and guilty is 0.18 times 0.88 because I'm just working my way down the tree. 0.18 times 0.88. And then the probability of being found guilty, we'll look up at my yellow highlighting that I've already done. Probability of being found guilty is actually the same exact question as letter A. So remember, there were two ways to be guilty. You could be a witch and guilty, or you could be found guilty even if you weren't a witch. So those yellow highlighting things are exactly what my denominator is asking about. And that answer was 0.2896. I already crunched that number, so I'm just going to pull that from down here. If you want, that's the same exact question as letter A. So you can make a little note about that. Anyway, so pop that number into your calculator, 0.18 times 0.88 divided by 0.2896. It gives you 0.547. And so as you can see, after you get your numbers organized in a tree-like fashion, the questions being asked should be very simple. And there are many different ways to ask questions involving a tree diagram, and that's kind of how the quiz is going to be too. It's going to be like draw a tree, answer a couple different questions. So let's look at example number 2 about media usage and good grades, meaning do you use media? It's talking about the influence of media in the life. So like light media users, meaning, I don't know, you watch YouTube, you look on Instagram all the time, that kind of thing. Moderate media users and heavy media users, meaning I never put my phone or my iPad down. I'm always checking stuff, whatever. And so what kind of media user are you? We're given 3 numbers here. 17 are light, 62 are moderate, and 21 are heavy. And by the way, those 3 numbers add up to 100, so those are my only 3 categories. I'm going to start my tree, and I'm going to spread them out. So I've got 17% as light, so 0.17 light. 62 is moderate, so 0.62 moderate. And the last one is 21 as heavy, 0.21 heavy media users. Okay, and then of those users, they're reporting like, do they get good grades or not good grades? And so those are the 2 options. Of the light users who responded, 74% say they got good grades, which again, you guys know there's a hidden percentage in there, 26% not good. That's what that means. So good grades is 74, which means the remaining 26 bad grades, aka not good grades. Okay, moderate users, we're told that 68% got good grades, which means the remaining, what would that be, 32 bad grades. And then of the heavy users, we are told that 52% got good grades. Notice how that's the lowest of all the 3 in the good grade category because they're heavy media users. Apparently they're spending too much time on Insta. Therefore, they're not spending as much time on their grades. So here's my tree diagram. And now I'm going to try and answer some questions. According to this study, what percent of young people describe their grades as good? Okay, so in this case, good, there's 3 different ways to have good grades. You could be a light user and have good grades, that's option 1. Or you could be a moderate user and have good grades, that's option 2. Or you could be a heavy user and have good grades, the least likely probability there. Anyway, so that's the math that I'm going to show. I'm going to write it out in words first. It's probability of being a light user and having good grades, or probability of being a moderate user and having good grades, or which is plus, probability of being a heavy user, and having good grades. So those are the 3 different ways to be categorized in this tree as having good grades. So again, we just multiply for light and good. You multiply working your way down the tree, 0.17 times 0.74. And then for moderate, 0.62 times 0.68, just multiplying my blue numbers together. And then for heavy, 0.21 times 0.52. Adding up all 3 of those numbers together, we end up with 0.6566. Check that in your calculator with me. That means 66 almost % of the people in this age bracket, 8 to 18, in this study describe their grades as good. What % of youth with good grades, that's the given condition, so given good grades are heavy. So the probability of heavy users given good grades. So that's my given condition, is what percentage. I'm only looking at the youth that have good grades, so that restricts the tree a little bit. So I'm only looking at the good grades students. In this case, there's a formula for that. I always like to use the formula whenever possible. That means heavy and good grades divided by probability of just good grades. Remember how it's not mathematically accurate to say that this is the denominator, but it looks like the denominator. So the given condition is your denominator here. Even though that's not a division bar, that's how I like to look at it to help me remember that the good goes in the bottom, or the given condition goes in the bottom. So looking back up at my tree, how can you be a heavy user and get good grades? Well, 0.21 times 0.52 is that. So 0.21 times 0.52 divided by, what's the probability of having good grades? That's exactly this question that we already answered. So remember, this question is, what's the probability of having good grades? That's exactly what this denominator is asking. So we already did light and good, or moderate and good, or heavy and good. This number goes in the bottom here. So 0.6566. Again, make a little note if you want to. That number is right there. That's how you get the denominator. In this case, once you crunch that number, you get 0.1663. And that, my friends, is tree diagrams. So tree diagrams are one of my favorite ways because it helps you organize the information, but also really simplifies the question. So we will practice some of this in class tomorrow. You guys are awesome. You're almost done with this chapter. Keep up the good work and have a good night.